Alright, so the main reason we have Mastercam is so that we can use it to write CNC programs. So in this session I want to draw this part right here from scratch and then put some simple lathe toolpaths to it. So you can see this part is about 4.5 inches long, 875 thousandths in diameter in the front and 3 inches in the rear. So let's start drawing this from scratch. That will help you see the menus necessary to create all the angles, chamfers, and radii. We're not going to do the solid portion of it. I'm doing that just as visual aid right here. But we're going to use the 2D model for our toolpaths, and it'll be a simple introduction to CNC lathe programming. Alright, I want to show you real quick the dimensions that I'm going to be using to create this part. So we're going to start from scratch. I just want you to see where I'm getting these dimensions from. Alright, the first thing you want to make sure of, which is very important, that your construction plane and tool plane is set to top. So if you look in your lower left hand corner, you need to have G view, the WCS, and the TC tool and construction plane set to top. So click on G view, make sure that's set to top, and planes to top. Alright, then you can toggle this 2D to 3D, make sure it's set to 2D and that you are set at 0 right here in this field where it says Z. That means we're going to be drawing right at Z0 plane, and that's where the CAM file wants to see the geometry of our profile. Alright, so let's get started with the drawing. Alright, the first thing you need to realize is that right here at the intersection of these two lines, which are going to be the X and the Z axis for the lathe, at the intersection right here we are right in the middle of the spindle and right at Z0, which is the face of the part. So we're going to be drawing in this upper left hand quadrant of these 4 quadrants. Alright, now I want to be drawing only half the part, the top half of the part, and then I'm going to mirror that shape so that you can see the full diameter of the part. So all the X diameters I'm going to draw half the size. Alright, so the first thing we're going to do is go up to create and select a rectangle. That opens up the rectangle menu, and we're going to let our cursor snap to that origin, and we're going to left click, and then you just drag it, and we know our part is 4.5 inches long. So if you look right here in this field, you just drag it close to 4.5. You're not going to get it on the money, but close is good enough. Alright, then our finished diameter is 3 inches, so half of that is 1.5, so that's close enough for eyeballing. We're going to left click again, and then you just go into this field right here. That is the length, that is minus 4.5. And then you hit the tab key, and that is going to be 1.5, and then you hit this blue apply button. Alright, so now the length is 4.5 inches long and the height is 1.5. So this bottom line represents the very center of the part. Okay, so then we click on the check mark and we end our rectangle shape. So now we have the basic shape of our part, and now we're going to draw in all the details. Alright, so the next thing we're going to do is draw the diameters. We're going to go back up to create. We go to line, endpoint. Now notice right here on the menu we have vertical and horizontal. Now we want to make sure that horizontal is highlighted, so just you can either toggle that on or off. Okay, so make sure that's on. Then on the front we have an 875 diameter. So what I'm going to do is I'm just going to draw a line roughly 1.5 inches long. Now I'm looking over here for that length. Okay, now when I clicked right here and ended that, it put in a value right here in this box. Now that's going to be an 875 thousandths diameter, so I'm going to key in 875 divided by 2. Let the software do the math for you, and then click on this apply button. So now that line is sitting at 437.5, which is half of the 875. So we're going to do the same thing for the 1 inch 6 diameter. So I'm just going to draw a line right here roughly and you can see that's sitting at 1.07531, so I'm going to key in 1.6 divided by 2 is 8, puts that line on the right diameter based on the calculation we just did. Okay, so again we hit the apply button. Now I want to draw a couple of vertical lines, so I'll make sure I click on vertical and highlight it, and I'm just going to draw a line right there. So when I completed the line, you can see the value, and that needs to be minus 1 inch 250. Okay. Alright, so the next line that I have is 4 inches, so that's roughly right here. And you can see I got that pretty close, minus 4 inches. And those are the only lengths that I know. So I'm going to go ahead and click the apply button and then hit OK. So at this time, we can open up our trim, break, and extend. If you look over here, you see that little scissor icon. Left click on it and it opens up this menu right here. Now we're going to trim 2 entities. So you can see this second from the left is highlighted, and make sure that your trim or that little scissor is highlighted. So what we're going to do is we're going to trim 2 lines. So I'm going to trim this line to that line, and you can see before I click on it, you can already see what it's going to erase. The dotted line is going to be erased. Okay, so I want to trim that to that. Make sure you don't pick that, because then it trims the wrong side. So make sure that you wand over the portion that you want to keep. Okay, so I want to keep that, and then I want to keep this and this, so you can see that's the portion that's going to erase. And then I want to keep this and this, this and this. Now it's starting to look more like a part. Alright, so at this point we click OK and we're done trimming. Alright, so the next thing we're going to do is draw the 10-degree line that starts at this intersection right here. So instead of going to create at the top of the screen, we're going to go ahead and click on this icon and select create line endpoint. Now the first thing you want to do is make sure that horizontal or vertical is not highlighted, otherwise it's going to force that line to be horizontal or vertical. So now it allows me to snap to one side and then move it at any angle that I want. So I'm going to just put it at any angle and just end the selection right there. Then in this box we're going to enter 170 degrees and click apply. Now if this line was laying flat, it would be at 180 degrees, so 180 minus 10 puts it at 170. So we say OK. We're going to go back into trim real quick. We're going to keep this line and this line, this line and this line, and then all that's left to do is highlight that line and click on this little eraser where it says delete entities. So hit delete. So now we have our 10-degree angle. Alright, so all that's left to do now is some radii and chamfers. So we have a chamfer right here on the front of the part. So again, we'll go to this little icon, and you see this little arrow with the pull down menu, and we're going to select chamfer entities. That opens up this menu right here, and we have a 1/8 by 45 degrees. So you can see this is already set at 1/8. It's at 45 degrees. So the next thing you do is you select this line and that line, and it automatically trims the excess, and it draws your chamfer right there. So we end the selection by clicking OK. Alright, so then we have a radius right here between these two entities that is 1 inch. So again, we go to this little pull down menu and we select fillet entities. Then right in this field here, we're going to put 1 inch. Notice when I wand over this little icon, it says radius, so that is a 1 inch radius. And I want to put the radius between this and this. So you got to click both of those entities, and then it will put that 1 inch radius. You can see that that blue section right there is now that radius. Alright, so we click apply, and then we're going to change it to 0.375 because that goes to here. So we click on this and we click on that, and you can see it automatically puts that radius right there in that corner, and we say apply, and then we click OK to end it. So now we have drawn our complete part, but we only have half of it. So for visual reasons, we're going to go ahead and zoom out. We're going to select the whole part, and then we go to this little icon. It says X-Form Mirror. Okay, so click on that, and we're going to select copy, and right here when you want over this top icon, it says X-axis, select point. I'm going to put a little check mark in there, and now you can see it mirrors across the X-axis, and then we click OK. And now notice the two different colors. The red color is the original, and then the purple color is the resulting mirror image. Okay, so we click on this little icon up here and it says clear colors, and now we're back to black. Alright, so now we have completed the drawing of our part. So now we are ready to start machining. Alright, so the first thing you need to do is take a look at the operations manager on the left, and you see these different tabs. One of them says toolpaths, the next one says solids, and you may have art. Make sure you select toolpaths, and if you don't have the lathe default machine group active already, go up to the top where it says machine type, wand over lathe, and select default, and then it will show up just like it does here. Alright, so once you have that, click on the little plus next to properties, and then we're going to click on stock setup. Alright, then this menu opens up. You can see the left spindle is what we're going to be using for our stock. That's the first thing we're going to do, is create stock around our part. So the next thing you do is click on properties. Alright, the first thing you want to make sure of is that under geometry we are set to cylinder. Then the next thing we're going to do in OD, we're going to enter 3.25, 3¼ inch diameter stock. And then for our length, let's go ahead and put 7 inches, because we're going to have some of that material up into the chuck, and we need to have at least 4.5 to 5 inches hanging out of the spindle. And then in the field right here under Z, position along axis, we're going to put 40 thousandths excess on the face of the part. Alright, so at that point you just click OK and click OK again. Alright, so now if you zoom out just a little bit, you can see the dotted line is a representation of your raw material. And if you zoom in, then you can see we have 40 thousandths on the face, and we have enough stock to clean up the largest portion of our part. Now the extra length is not critical. Whether you have a ½ inch or 10 inches extra, it does not matter. Okay. Alright, so let's start with the first toolpath, which is roughing the face. So what you do on the left side right here in the operations manager, next to the red arrow, you right click and wand over lathe toolpaths, and we're going to click on face. And then if you get this message, you just click OK. Then this comes up, you just click OK, and it lets you get into the parameters window. Alright, so first of all we need to select the tool that we're going to be using. And for this operation we're going to select tool number 12 with a 0.0313 radius. That is a 32nd radius. And so we just left click on it, and you can see it automatically puts the tool number in this field up here, the station number on your turret, and then the offset that we're going to be using in our program. The feed rate we're going to put at 5 thousandths per rev. Okay. Then the constant service speed we're going to put at 500, and we're not going to do anything with the finish spindle speed, but the max spindle speed we're going to put at 3500. Alright, so then we click on coolant. We're going to select the flood and switch it to on. We say OK. Then we put a check mark where it says force tool change, and under comment we're just going to put rough face. Then the next parameter up here, it says face parameters. The entry amount is 100,000, so it's going to ramp it to a point 100,000 above the part. Then put a check mark where it says a rough step over, and we're going to put in 20 thousandths. Okay. At this point, I would unclick the finish step over, and right here where it says stock to leave, enter 5 thousandths. Okay. So we click OK. Now it already did the toolpath for us because it looks at the amount of excess stock based on where the part is located and the stock that we created, 3¼ inches in diameter and 40 on the face. So it sees how much material is there to be taken off. The parameters that we filled out said, okay, start at 100 thousandths above the part, take 20 thousandths passes, leaving 5 thousandths for finish. So it had already done that. You do not have to select any geometry for this operation. Alright, so the next thing we're going to do is go back to our operations manager here on the left. We're going to left click next to the red arrow and then right click, wand over LATHE toolpaths, and we're going to click on canned and canned rough. Then it says right here in this little box, select the entry point or chain the contour. So what we're going to do is we're going to chain this whole contour that we want to machine. That is the OD. So on the left right here in this window where it says chaining, I want you to click on partial and then put a check mark in weight. Then we'll go over here to the very right side of the part and we're going to click the first entity we want to machine and kind of want your cursor to the bottom portion to make sure that those arrows go in the direction of the machining. Now if they show up like this with the green arrow and the arrows pointing in the wrong direction, you just reverse that toolpath by clicking on this reverse button. Alright, now the weight, make sure that this green arrow right here stays put. If you unclick weight, that green arrow tends to chase that red arrow around. Okay, so put a check mark in weight and we're going to click the rest of the geometry. So let's zoom out, make sure you click on every segment right in front of that red arrow until you get all the geometry selected. Once you have everything selected that you want to machine, click on OK. Alright, so that opens up this LATHE canned rough properties window, and we're going to pick the tool first. Now the one that is currently active is the tool 12, which is the 55-degree tool with the 30-second tool nose radius. So again, we're going to left click on that. That automatically puts these default values in these fields. Tool number 12, the feed rate of 10 thousandths. Again, we're going to use a 500 constant service speed and then a max RPM of 3500. We want to click in coolant. Make sure the flood is turned to on. Click OK. And this time we do not want to put a check mark where it says force tool change, because we use the same tool for facing, so we don't have to make a tool change to transition from facing to OD roughing. So we leave that unclicked. And then in the comment section we type rough OD. Then the next tab, it says canned rough parameters. Click on it and it's going to put together a G71 roughing OD can cycle. Now on Z we're going to leave 15 thousandths and on X we're going to leave 30 thousandths for finish. We're going to take 100 thousandths depth of cut, and right here where it says exit length or retract, we're going to put 50 thousandths. Okay. Then the rough direction right here, you have some options and you can see the different types of rough directions, and of course we are set to the correct rough direction, turning the OD. Then the next thing we need to look at is lead in, lead out. Click on lead in, lead out, and it says extend, shorten the start of the contour. So it automatically extends the contour by 100 thousandths, which is right here in the front, to make sure we're not crashing into material as we wrap it into position. The lead out, we're also going to extend by 150 thousandths to make sure we have enough material exposed for our cutoff tool to get inside. Then you click OK on that. Then the next thing you need to do is put a check mark where it says extend contour to stock, because the geometry we selected, the finished diameter of the largest diameter is 3 inches and our stock is 3 inches 250. So we want to make sure that we put a check mark. Now notice when I did that, right here you're seeing a preview of your G71 CAD cycle. When I unclick that, you can see the diameter that we selected in our geometry is 3 inches at the largest diameter, but extending the contour to the stock updates that to 3 inches 250. So now the G71 CAD cycle knows that there's more material to remove over and above the 3-inch diameter finished part. Okay. Alright, so adjust contour ends. You can basically see the yellow line and you can see a preview of the toolpath that is going to be machined. We just click OK and then again click OK. Now immediately it will give you a preview, but to simulate your toolpaths, simply click on this little icon right here that says Backplot Selected Operations. So left click on that and you have this little slide here that kind of controls the speed, and then you got some radio buttons here to play your toolpaths. So if you zoom out a little bit, you can see the toolpaths of your tool, the way it will machine your part. Alright, so we're going to speed that up a little bit. You see it takes one final pass, leaving 15 thousandths on Z and 30 thousandths per side on X. So then you just click on this OK and it gets you back out of that backplot mode. Alright, so then you want to get rid of these toolpaths. You go over to the Operations Manager and you click on Select All Operations. And then click on this little icon that says Toggle Display on Selected Operations. So that turns off all those toolpaths. Alright, so then we're going to go back to the Operations Manager. We're going to left click next to the red arrow. We're going to right click, Lathe Toolpaths, and Face. Now we're going to need to select a Finish tool. Now if you don't see the tool in the available options, then right click in this field and open up the Tool Manager. Now currently you have tool number 1212 with a 30-second radius. Now if you want to use a similar tool but it's not in your library, then go ahead and right click on that tool, select Copy Tool, then right click again and Paste Tool. And it will give you a warning saying a similar tool 1212 already exists. Add another, yes. So here you can see it makes a copy. So then right click, click on Edit. We still want to use a 1/32 tool nose radius. Then on the holder, we're still good. Parameters, let's make that tool number 11. Change all this to 11. Feed rate is going to be 6 thousandths. Constant service speed 500. Going to turn the coolant to on, and we're going to make this description right here. Going to get rid of this. Finish OD 50° right. Then we say OK. Then we click on that. Click OK there. And now it should show the tool number 1111 we just created. So when we click on that, it brings in everything that we just changed when we were editing that. Okay, you can see tool number 11, feed rate of 6 thousandths, 500 constant service speed with a max RPM of 3500. And if we click on coolant, the flood is turned on. Alright, so now this will require a tool change because we are changing from tool 12 to tool 11. And I'm going to enter a comment saying finish face. Okay, then we go to the next tab that says Face Parameters, and now we're going to unclick Rough Step Over, and then automatically you can see Finish Step Over got a check mark, and Stock to Leave, we're just going to put the 0. Okay, so we'll just click OK. And it automatically sees the amount of material left, and it also knows that all this other material on the OD was removed. So it rapids to this point right here in phases, and it automatically does that without having to select the geometry. Alright, so the next thing we need to do is finish the OD. So again, we're going to go to the Operations Manager, left click next to the red arrow, right click, LATHE Toolpaths, and Finish. Then instead of selecting geometry again, click on Last. And when you click on Last, you can see the last geometry we picked was all the geometry of the OD. So that's all we need to do. Click OK. Now we're going to select tool number 11 again. We don't have to put a force tool change because we already have that tool active when we finished the phase. So we're just going to put a comment in there, Finish OD. Then under Finish Parameters tab, click on Lead In, Lead Out, and on the Lead In tab, let's switch this to 135-degree angle, and that's kind of in line with this chamfer on the front. Okay, that's going to extend that by 100 thousandths on the approach, and then on the lead out, that is the retract move at the end of the geometry. We're going to extend that geometry by 130 thousandths. So make sure you put a check mark in there, 130, and make sure that extend is checked. Okay, so then we click OK, then we click OK, and then we go back to Backplot Selected Operations, and you can see that it is in line with this 45-degree angle at about 100 thousandths approach. And we'll click play, and you can see it just takes that 15 thousandths off of all the Z values and 30 thousandths off of the X values. Then it stops just a little bit shy of this little excess material and backs out 100 thousandths away from the material before it rapids back to home position. Then we click OK, and we are ready to cut off. Alright, so we'll go back to our Operations Manager. We left click next to the red arrow, right click, LATHE Toolpaths, and Cut Off. Then it says Select Cutoff Boundary Point, so we're going to let the cursor snap to this point right here at the largest point of the part. Click on that, and it opens up your LATHE Cutoff properties. Alright, so we're going to select the tool. This is tool number 4444, and let's go ahead and right click on that, and we're going to edit. Now this tool right here on D is 125 thousandths wide, that's okay. C 10 thousandths, let's make that 5, and the rest is good. Then we'll go with holders. Now this C dimension is going to have to be longer because the part is 3 inches in diameter, so that's got to be a minimum of about a 1.6 to have clearance. Then under the parameter tab, we're going to call this tool number 1. So we'll change everything to 1. 2.5 thousandths feed rate is okay. We're going to still go with 500 constant service speed. Click on coolant. I'm going to turn it on. Say OK. And say OK. Now you can see it brought all those values in. We got tool number 1. 2.5 thousandths per rev. 500 spindle speed. And the only thing we've got to change is the maximum spindle speed of 3500. Click on coolant. We already put that on, so we just verified that it did. We do want to check the force tool change box because we are making a tool change obviously, and we're going to call this cutoff. Then we go to cutoff parameters, and the entry amount is 100 thousandths above the part. And we're going to make sure we put a check mark in from stock so that we don't wrap it into our raw material. Then we leave everything else like it is and we click OK. With only this folder selected, we click on Backplot, and you can see it rapids to 100 thousandths above the raw material, and then we watch it cut off the material. Alright, and at that point we are done writing our program and we are ready to post. Alright, so when you get ready to post, right now we only have a check mark right here next to LATHE cutoff, and all these other little folders right here are not checked. So make sure you click on Select All Operations. Then we select G1, which is Post Selected Operations. And you want to make sure that you have a check mark in the NC file and Edit, and then Ask. Alright, so your post-processing window needs to look like this. So we click OK. Then the NC file is called a shaft, so that's okay. We hit Save. And then this is what your program would look like. You're going to have to manually fill in a program number, and here's the program name called shaft. Now there's a bunch of other information that you may not want to keep in your top of the program, but what we're after is we see the rough face operation using tool number 12, then a rough OD using the G71 can cycle. Then we make a tool change to tool number 11 to finish the face and finish the OD. And then we use tool number 1 to do our cutoff. Alright, so I'm going to go ahead and stop right here. That was a lot of information on the basics of toolpaths. Let me know if it helped you. Thanks for watching.